Alright, class, let's begin. This is chapter 5, and these are the 3 questions that cause some difficulty when doing chapter 5, so let's go with it here. This is chapter 5 and 333-T. I believe it's question number 8 on the homework here, so let me put in 8. There it is. Okay, so let's go with it here. So per capita, your numbers may be slightly different than mine. So my mu is 2286 kilowatts. Standard deviation is 571.8 kilowatts. So this is consumption of energy in kilowatt hours, kind of like running the electricity in your house. For a certain country in recent years has been approximated by a normal distribution. You could tell it's normal because of the way it looks here. So the question is, what consumption level represents the 5th percentile? So just real quickly here, just so you know, the 5th percentile, when you're talking about percentiles, right, they go up from 0% all the way to 100. So if you're looking at 5th percentile, you're looking at the 5% marker. That's what you're looking at. And so before we get there, we go back to our, and I got some of the work here already, we go back to our z-score. Remember that one from earlier in the class? And what we want to do is we want to go from, instead of solving for z, we want to solve it for x. So that's kind of all we're going to do real quickly here. So let me do that. Let me make sure my pen works. Okay. So all we're going to do is we're going to multiply both sides by standard deviation, like that. And that's going to cancel standard deviation on the bottom. Let's see, we're going to add mu to both sides. So plus mu, and we get ourselves the equation. We don't like it solved. We like x to be solved for. So here's our equation that we're going to use to set this up. And remember, standard deviation, normal distribution, there's percentages in there, right? So we have to figure out where is 5%. And we're going to do that. We're going to based upon the chart. So let me do this here. Let me go to the chart first, because I think that'll make more sense. And so this is a table that you can Google this table. It is inside the back of your textbook as well. So you can take a look at it, but we're going to find where in the world is the 5%. That's what we want to find out. So it all depends on the percentage that's listed in here. So that's like 0.03%. So all these percentages, remember changing a number from decimal to percentage, right? We move the decimal place over. So right, so 0.0003 really converts into 0.03%. We just moved the decimal place twice. So that's not even 1% yet. So we move down the pile here, and we notice that right over here, if you notice right there, it's right there, this is a point. It's like right in between these two dots right here. So 0.0495 and 0.0505. So if we move the decimal point over, this would be 4.95%. This would be 5.05%. So notice they are exactly 0.05% off. Okay, so the z-score that determines this one. So this is negative 1.6, and this is 5 and negative 1.64. But notice they are exactly 0.05% off. So what we normally do is we say, okay, it's going to be right in between here. So what's in between a negative 1.65 and a negative 1.64? And the average between the two, or the middle of it, would be a negative 1.645. And that's what we use. So that gives us the 5% of the area that's underneath that curve. That's what a normal distribution looks at. Okay, so let's back up. So I'm going to use that number into this right here. So the mu comes from our given. We just found the z-score that matches up to 5% on the left side of the normal distribution, and standard deviation goes right into there. Plug in those values in. We should get a value of, I don't know, I actually forgot to plug it in here. Let me do that right now. So x is equal to, all right, let me bring up my handy dandy calculator here. So hopefully you guys have a little calculator here that you can do this with here, but really just punching in numbers here. So this is 2286 plus a negative 1.645 multiplied with 571.8. Voila, and we should get something familiar. 1345.3, and this says round to the nearest integer. Awesome. So it's going to be 1345. That's the 5th percentile of this. So real quick here, I guess we should say, what does this mean? What does this mean in actuality? It means that in a certain country, the way energy is used in a household, let's say it's per month or per year, right? It's a normal distribution. And so 5% of the population use 1,345 kilowatt hours or less. That's what that means. And let's see, where is that at? That's probably like somewhere right over here somewhere. Maybe just a little bit further than that little point right there. Maybe like somewhere like right over here. That's kind of what we're looking at. So that little 5% marker. Okay, so plug that in, and based upon this table, and voila. Okay. What's up with that? I'm kind of off a little bit here. Okay. Next is find the 24th percent. So that's number 1. Sorry, switching back and forth here. Let me get my pen so I can mark off things here. So that answer should be 1,345 inside there. That's the 5% of the population use that much energy or less. Let's look at the 24th percentile. It's not the 25th percentile. It's not a quarter. It's almost at a quarter. Okay, so let's go back to our graph. Boom, boom. And we're going to look for 24%. 24% is going to be somewhere. Ooh, notice it's like right here. So notice I have 0.2389. Then I also have 0.2420. Okay, so the number's somewhere between these guys. Not like the first one that we did. Notice in order for me to get to exactly to 0.2400, I need to add 11 right here, right? So I'm 11 off on this guy. If I were to go backwards to get to 24.00, I'd have to subtract 20. So notice this one actually is closer. This is closer by 0.0009 units. So I'm going to use this number. And that number corresponds to negative 0.7, and let's see where 1. There it is. Okay, so for my z-score for the 24th percentile, I'm going to use negative 0.71. So let's calculate that guy. So there it is, and I forgot to calculate it again. Let me do that. So there it is. Notice the numbers all stay the same. This is going to be, you know what, I'm going to put in my entry from last time here. I'm going to go like this. Boom. Love it. So let me just delete this guy here, dude. Nope. Deleting from the wrong side here. Delete, 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 delete. And you could just type it in all over again if you like, but I'm just kind of showing you a few little tricks here. And this is an insert button. I inserted the previous parenthesis here. Let's see, it's going to be negative 0.71, and now I'm getting into a whole bunch of stuff here, so I'm going to actually just kind of fill it all in here. Sorry. 571.8, voila. Close off that guy. Enter 1,880. So almost a quarter of the nation will use 1,880 units or less. That's what that means. Okay, so let's go back now to our previous problem here. So the answer to this guy would be 1,880 kilowatt hours. And maybe it'll be kind of interesting. Can you go to your, if you have your like PG&E bill or something like that, just see how many kilowatt hours you use for last month to see if it's kind of close to the numbers here. All right, and letter C represents which consumption level represents the third quartile. So remember, quartiles are like this. They're things that are broken up into 4 pieces. So really, things that are broken up into 4 pieces are really 25% pieces, right? So first quartile is 25%, which would have been very, very close to this little 24th percentile. The middle one is now another 20%, really with 50% right here. And the third quartile would be at 25%. Okay, so what we have to do here, because it's past the 50% marker, we can't use this standard deviation distribution, because notice the areas on this side, areas on the left side of our middle column. And when you get to the exact middle, you're going to get to 0, 0, 0 for your z value. So to go above the 50% marker to have your z-score, we're going to have to use this one right here. And I kind of already gave you the answer over there. So let's find 75%. Let's see if we can find it here. I'm looking. Okay, I see 17. Okay, I see a point. I see a 0.7486. And then afterwards, I see a 0.7517. So question is, which one of those is closer to exactly 0.75? So this guy looks like it needs another 14 units to get to 0.75. This guy looks like he's over by 17 units. So he needs to go backwards by 17. So this guy wins. This is the closest. So we go this way. This is going to be 0.67. Alright, that's where we get this number here. And that's what that arrow is all about. So 75th percentile has a z-score of 0.67. Plugging in that value into this, and this one I actually did. So 2,669 kilowatt hours is what 75% of the population uses. Alright, and I clicked it in just to make sure you know that I did it correctly. There it is, 1345, 1,880, and 2,669. Okay, I checked my answers as well, just to make sure that I did it correctly here. Okay, jumping on to the next question. And this one, I started the work already, and I forgot that I didn't start it already here. So let me do this here. Let's recalculate that. In fact, there's so many parts to this question, so let's go for it. This is 5.4.13. So we are in 5.4, and 5.4, I believe this is question number 6 in that section. Okay, so let's go for it here. So I'll let you guys read it for yourself. You have a question that's very, very similar as well. But find the mean and standard deviation of the sampling distribution. Compare that with the mean and standard deviation of the population. So again, the scores of 3 students in a study group on a test are 91, 96, and 93. It says use a sample size of 3. Ooh, I hopefully still have it up. If not, I'll have to go to it here. So let's see. So first of all, the mean. Mean is easy. You just add up the numbers and you're done, right? Right there, that's going to be 9, 10, that's going to be 27, 28. Then we divide that by 3, and just use a calculator if you need to be here. Here it is. Thank you, it turned off. Wow. Alright, 91 plus 96 plus 93, and we're good to go. Divide that by 3, and 93.33. Great. Okay, standard deviation is a little bit more complicated. So let me get to this problem here. All right, perfect. It's still up. Okay, this is the problem that I did. Your numbers may be slightly different. Okay, but let's go through each of these pieces here. So the average, we just learned that was just a quick little add up. The numbers divide by 3 because that's the sample size. The standard deviation, let's talk about this one because this one's a good one to talk about here. So this one, notice the scores of students in a 3-group study, or a study group, were given like this. So this is the population, right? And so when we click on here, let's open this. That's what this little button for. It says open in that crunch, and we'll open it in Excel, see what happens here. If it'll open, hopefully it will. Okay, StatCrunch, pretty good software. Hopefully you guys have used this before. So what we want to do is we want to go to Stats. We'll want to to go to summary of the stats, and we're going to use a column because we're going to use this column here to get stuff. We're going to get a summary. So the column that we choose, because there's only one column here, so variable 1, and we want to know, hey, this would be good. Let's find out the number that we're using, and you have to hold down the control key on your laptop, and then you want to go the mean, and we want to go standard deviation, and we want to, okay, I'll save it for you. Let's click compute. So it tells you the column that we're doing, tells you how many were, because there's 3 different numbers here, 1, 2, 3. The mean, which is what we calculated, and then you go standard deviation. The only little problem is that is not the standard deviation. This is the standard deviation of a sample, not the population itself. So what we're going to do, let me go back over here, stat summary, column, and I'll give you a little, that one, mean, standard deviation. I'm going to go all the way down here called unadjusted standard deviation. That's the one that we want. So click compute, boom. Okay. The unadjusted standard deviation is 2.05. That's what we want to put as our answer. We good? So that is, so the question is, hey, why is that different from the other one here? So let's talk about it. I think you'll see it as we go through it here. So if you open this up in, let's click out of here. Sorry, boom, forget that. Let me go back to the problem itself. Let's open it in Excel, because Excel will give you a little bit more understanding of it. If you don't know how to use Excel, oh, you know what? I already have it opened up. Hold on. You should learn. This is good to learn. So let's go with it here. Let me erase what I had before. And you know what? Let me redo this here. So once you click Open Excel, you're going to have a little ribbon that says, do you want to edit this document? You click Edit, and you get to something looks like this. All right, so here's what you want to do. You got 3 different data sets right here, right? You want to go over here somewhere on the page. You're going to put equal sign. And what that does, that starts a formula list for you. So you can enter stuff here. And so click on function. And Excel has a whole bunch of different functions here. You can do a whole bunch of stuff with Excel. It's so versatile. You can click on all. And these are all the different functions you can do with a whole bunch of different things. So the first one is like absolute value of a number. Look at that. I think you know that from algebra. Right, you want to get absolute value of numbers? There it is. Okay, what we're interested in is this little statistical menu right here. And if we want to, we can get the average. Let's do that. Average of a number. Click yes, that's what I want. So then it's going to ask you what are the numbers, right? So you're going to just highlight them like this. Click enter. Voila! See something like that? I think we've seen that before, right? Okay, let me show you the 2 other ones here. So again, click enter. Go jump to function. We're in stats now, right? And so as you scroll down to the S's, let's go down to the S's. Again, there's a whole bunch of stuff here. So we're going to click on, hey, look at that, standard deviation of P, which is the population. So calculate standard deviation based upon the entire population given as arguments. Okay, let's click on that, and it's going to tell you what numbers we're going to use. We're going to use these numbers here. Click enter. Hey, look at that, 2.05. So clicking on one more. Okay, one more. We're going to do one more. So equal sign, function, boom. And we're going to go down to standard deviation. But this time we're going to do standard deviation of sample. That's what this guy says here. Estimate standard deviation based upon a sample. Click on that, boom. Give me the numbers, boom. Click enter, voila. Hey, that is slightly, is it the same? Let me check. Is that the same that we got over here? Using StatCrunch. I think so. Sorry, I'm going to go back real quick here. See if that is the case. Stats, summary of stats, columns, variable 1. You know, let's compute all of it. There it is. Yeah, there it is, standard deviation. So that piece right here, 2.5166115, that is the sample deviation. This is the population standard deviation. That's the mean right there. And you can write in here as well if you wanted to. You can say mean And then you can say ST of population. Then you could put ST. And okay, we'll do that. That's of sample. There it is. I guess I should be more specific. Population. Okay, that's cool. All right, so Excel, very versatile tool. I hopefully know how to use it. If not, learn how to use it. It's really, really good. I use my budget. I do budget this way, as personally, because it calculates everything for me. Okay, so with that said, let's go back up to here, I think. And so the question then, we got that one. Hopefully that's taken care of. Hopefully you know that now. All right, identify all samples of size 3 in the correct accompanying means below. So real quickly here, if you turn to page 22 of your textbook, it talks about replacement or non-replacement. So this one's replacement. So you're saying, okay, if this is the whole entire population, there's only 3 numbers here, and I'm trying to make a sample population with replacement, which means if I pick, let's say 91, 96, 93, if I pick a 91 out of the population, I refill it with another 91. So I have the ability to choose 91 again. So the part 3 of this question, identify all samples of size 3. And notice I clicked every single one of them, because every single one of them had either a 91, 96, or 93 inside its sample. So it was almost like a trick question. That's all it was. Trying to see if you got that. Okay, let's go on here. So as long as these guys repeated themselves, if you had a 94 somewhere in here, and there's no 94 in the study group, then that could not be a sample. We're good. That's what I just want to show you. All right, so what is the mean of the sampling distribution? And the mean of the sampling distribution, if you needed to know that, it means that the sampling mean and the distribution mean are going to be the same. You're going to add up the 3 numbers, divide by that one. Okay, the standard deviation is a little bit different, so let me go back to my PowerPoint here. Got that. Okay, let's talk about this guy here. So how do we get the standard deviation of the sampling distribution? What do we do there? All right, and so real quickly here, let me find the formula for it real quickly here. It's this guy here. So it's there's your standard deviation of a sample mean, and the formula for it is the standard deviation divided by the square root of n. So how many people in there in the first place? So the population standard deviation is 2.05 divided by the square root of 3. And if you do that on a calculator here, just quickly do that, you wind up with a 1.18. That's what that one is all about right there. Boom. Okay, so then we compare stuff. So the question is, are the means the same? Yes, we had a 93 here, and we also had a 93.3 up there. So the means are the same. So that guy is off. That guy is off. Now the question is, the standard deviation of the sample, is that higher or lower? So this one's off because the standard deviation are different from each other. And so the standard deviation of the sample is going to be a smaller distribution than the population itself. Think of, you're talking about maybe like income differences between 3 people, or income differences in the whole entire United States population. Obviously the sample is going to have a smaller distribution, so that's what that guy is all about. Alright, so good to go. Hopefully that one is now better for you. And we got one more, I think. Alright, this one. Okay, another slight tricky one here. So the population mean, the standard deviation of a given below. That's great. Find the indicated probability and determine whether the sample mean and the given range below consists of usual. Okay, so let's go for it here. So whenever I think of this, I always think of a normal distribution. And it says that there's n is equal to 33. Let me just kind of put that down. Boom, boom, boom. And it says that the probability Given a sample, given sample, the probability of sample mean being less than or greater than that. Okay. Okay, mu is 12,749, and standard deviation is 2.2. Whoa, that's a very small standard deviation for something that large. So 2.2 units already carries out so much. Okay, what do we got here? This is why it's a trick question here. So let's do this here. So for a given population, the probability of a sample being less than 12,749 or greater than this number. Okay, so question, this is where it gets tricky. Notice that that number is the same as this number here. And so what we have here, because the mu is the same as what we're trying to calculate, we already have, so there is your 12,749. Because they match up, this is already 50%. In fact, it's exactly 50%. So there's that. Now the question is, if you go out to 12,752, where will you be? And is right here is there stuff here? And so we want to find the z-score that's going to make this happen for us. And so the z-score is going to be, and let's actually talk about this here just a little further here. So let me get to my page number that I want to view it on. There it is. Okay. So do you guys remember in the textbook that this is the way we normally write it for a sample, right? Now the only little thing is, notice how many numbers we have. We have 33. Sample size is 33. Whenever the sample size is going to be greater than 30, we can assume that it's going to be a normal distribution, just because we have enough samples to make it normal. It's not skewed data anymore. So we do this, we change it to this right here. Okay, all this stuff means something. Okay, so let's go for it here. So we assume that the sample mean and the mean of the population, you can just assume it's going to be the same. Since we went beyond 30, it's literally always going to be the same. Okay, and then this one we used last time. We take the standard deviation and distribution of the sample, and that's our formula for it. And so what we can do is we can say, okay, that the average, now we're trying to find this, right? We're trying to find the z-score to this guy. So z-score of, let's see, 12,752 minus 12,749 over 2.2 square root of 3. So really becomes 3 divided by 2.2 divided by the square root of 3. Okay. All right, and before we put in a calculator, I better put the exact correct numbers on here. It's not square root of 3. It's actually the square root of 33, because that's our sample size. There you go. That's better. 33, the sample size. And so 3 divided by 3.3 divided by square root of 33. So let's get the calculator going. Let's see what this value is. So this is going to be 3 divided by, and what I want to do is I want to put this in parentheses because I want to have that in the denominator still, so 2.2, and that being divided by the square root of 33, and then let's get out of that, let's close off the parenthesis, and we are good to go. Enter. Okay, so 7.833, that is a z-score that's off the charts. Was it 335 or something like that? Let's see, 335. Okay, so notice on your table, whenever you do a z-score table, you go out on a z-chart, you go out to about 3.4. 3.4 is the highest you go out. Let me see if I can go back to, let me get my mouse, let me go back to the table that I had before. Dun, da, da, da. Let's see if I can show the very bottom. Yeah, so notice you got a z-score. 3.5 is pretty much the highest. At this point you got 99.98% of the population. That's not going to add anything here. So let's go back to our problem, see if this makes sense. So this guy's not over here. This guy's like way over here on this end. That's where this guy's at. So I have 50% here, right? And then on this side, literally it's just 0%. We don't even add that much into it. So how much of it? We're going to go back and say it's just 50%. So let's see what we punch in. There it is. So 0.5000, 50%, because the other side was just too big to even think about counting. Okay, and then the second part is this right here. Would the given sample mean be considered unusual? And I was playing around with the questions here. So the sample mean would not be considered unusual, and because the probability is greater than 0.05, and the sample mean being within the range. So yeah, you just look at this problem right here. Is it unusual? No, it's pretty good because it at least has some kind of percentage in there, and the percentage is bigger than 0.05. That's all. Okay, so that is it for chapter 5. Oh, and this problem here, I didn't do this in the beginning here. This problem is number, let's see, what is that? Number 7. This is number 7 off of 5.4 homework. All right, hopefully that helped you in figuring out some of this stuff.